One. Final unit of the year. Unit 8 is data analysis and statistics. So we're doing the prior knowledge activities today. We are going to be talking about probability and data collection throughout this unit. But I wanted to get a little bit of a grasp on the information you know about probability. And then we have to review fractions, decimals, and percents. We covered that early in the year, like fall, like before the holiday season. So we need to review our fractions, decimals, and percents. Some of you finished your tests early yesterday, so you've done the first few slides. So just hang tight with us while we all do this together. But eventually we're going to start talking probability, and I'm really going to ask you for input either in the chat or using your voice throughout this lesson today. So your learning objectives is I can determine the probability of an event, so verbally, and I can express probability as a fraction, decimal, and percent. So I do have a picture of a calculator. It might not match yours exactly, but we need our calculators throughout this whole unit. We're doing a lot of computation. So in our final unit, woohoo, we'll be learning about probability, data collection, and interpreting data. You must know how to convert between fractions, decimals, and percents. We learned this in Unit 2 this school year. So we're going to watch this video, and it is going to remind us how to convert between percents, fractions, and decimals. So let's go ahead, sit back, hold tight. But again, we're going from fractions, decimals, and percents in this video. Okay, so hopefully this is going to start to ring a bell. Let's go ahead and watch it together.
It's Professor Dave. Let's do some conversions.
He knows a lot about all kinds of stuff. Professor Dave explains.
We've learned about fractions, decimals, and percentages, and we've seen how we can use any of these to represent the same value. So we certainly must be able to convert between these different ways of representing numbers. Let's take something like 30%. It's very easy to convert this to a fraction because we know that percentages are out of 100. So 30% becomes 30 100ths, or 30 out of 100. Then to reduce the fraction, we can divide both numbers by 10. And here's a hot tip. When we do this, we can just cross out the 0 in each number, as that will do the same thing as dividing by 10. That leaves us with 3/10. So 30% is equivalent to 3/10. Now let's get that as a decimal. Well, we know where the tenths place is. So if we have 3/10, we just need to place a 3 in the tenths place. So 0.3. And there we have 3 different ways of expressing the same value. Here's another hot tip. When converting from percentages directly to decimals, all we have to do is move the decimal place twice to the left, because 100 is 2 orders of magnitude greater than 1. So from 30%, we just take the decimal place, which isn't written, but is implied to be just to the right of the units place, and move it over twice to the left. We can never start a number with a decimal point. There has to be a 0 first. So that gives us 0.3. We could do the same with an 8.25% sales tax. We move it once, and then if we have to move it again, but there are no more numbers, just put a 0. And there we have 0.0825, or the sales tax expressed as a decimal. This is useful because if you want to compute the sales tax on an item, you can just multiply its price by this number. So a $50 shirt would have a sales tax of $4.13. To go from a decimal to a percentage, we just move the decimal twice to the right, because this is the same thing as multiplying by 100. So 0.84 becomes 84%. To go from a fraction to a percent, we could convert the fraction into a decimal first. For 3/5, first we can ask, what is 1/5 as a decimal? That would be 0.2, because 5 of these, or 5/5, would add up to 1. So 3/5 must be 0.6. From there, we just move the decimal over twice, adding a 0 since we need to, and we get 60%. Here is a table with some common fractions and their corresponding values as decimals and percentages. We should be able to convert between these forms with ease, as these are all just different ways of communicating ideas that are useful in different scenarios. Let's try and put this to use. Here are three values: 45%, 21/50ths, and 0.43. Let's try to arrange these from least to greatest. Well, 45% is the same as 45 over 100. What should we do with this fraction? Well, if we want to compare it to another fraction, it needs to have 100 in the denominator. So let's get this one looking that way too. Multiplying both numbers by 2, we get 42 over 100. And with the final value, we can move the decimal over twice to get 43%, which must be 43 over 100. Now it is quite easy to put them in order because they look the same. 42 comes first, then 43, then 45. That means that this will be the correct order for the original values. Let's check comprehension. Thanks for watching, guys. Subscribe to my channel for more tutorials. Support me on Patreon so I can keep making content. It's Professor Dave. Let's do some conversion.
Okay, perfect. So that should have been a review on how to convert fractions, decimals, and percents. Another graphic that I really like is this little triangle. So if I'm going from a decimal to a percent, I multiply by 100. If I'm going from a percent to a decimal, I divide by 100, so I do the opposite. To go from a fraction to a decimal, you all should be really good at this one. Anytime you take a test or get a score on something, you probably take your score and divide it by the total to figure out your score. So when you do that fraction, divide your numerator, denominator, it tells you your decimal. And to do the opposite, you need to take the decimal and use place value to find the fraction. And then finally, from a fraction to a percent, you divide the numerator and denominator, and then you divide by 100. And then for percent to a fraction, you rewrite your percent over 100 and then reduce it. And our calculators are really good at supporting us with this. Okay, so this is where I want your input. I am going to ask you to use the chat, and I'm actually gonna pause the instruction right now. And then that way we can turn our videos on and we can go ahead and participate, because this piece right here is gonna be huge in our unit. We have to remember how to do this. So I'm gonna push pause and then we can all do this together. Now. Okay, so if you were to have done this yesterday, I would have asked you to work on IXL for 10 minutes. We're gonna hold tight and we're gonna roll into probability. And then at the end, I'm gonna have you check in with IXL. So let's go ahead and talk probability. So again, last unit of the year, we're talking probability, data collection, and interpreting data. What do you already know about probability? So you can either put it in the chat, you're welcome to use your voice and be verbal. Probability, what do you already know? Give me some input, whether you have an example for us, whether you can define probability. Go ahead and give me some input here. Maybe you're like, I've literally never worked with probability in my life. I have no idea what that word means. I don't know. You can also be honest that way. So if you guys could give me a little bit of input, whether it's in the chat or verbally, you're telling me what you know. Yeah, so great job, you guys. Thank you. So yeah, Cameron had a really great example. If I'm going to flip a coin, what's the probability that I'm going to land on a heads? And that's exactly what we're going to start to chat about throughout the beginning of the unit. So we're going to talk about two different types of probability. Theoretical probability is what should happen when given an event. So an example would be determine the theoretical probability of the following events and write as a fraction, decimal, and percent. So Cam, you said, you gave us an example of flipping a coin. So I'm going to pick on you for this one a little bit. What's the probability of flipping a heads on a coin, Cameron? So let's think about this. How might you figure this out, Cam? And again, you guys may not have done full-blown probability yet, but let's make some predictions here before we get into our unit and deep dive tomorrow. So Cameron, I've got a coin. What's the probability of flipping a heads? Talk me through what you had told me while the recording was paused. You do not have to give it. So hold on, you don't have to tell me fraction, decimal, percent. We're gonna do that together. But what's the probability of flipping a heads? Give me some feedback, Cameron.
You have pretty much a 50% chance of landing on heads because you've got heads and tails.
Yeah.
And
you have a tails and a heads.
you got a tails and a heads, and that's so like heads is like 50% of the coin, and the tails is 50% of the coin, and together that's 100%. So yeah, you'd have a 50% chance of flipping a head.
I love how you're rationalizing this. Exactly. So again, we're going to talk more about this tomorrow, but you have a 50% chance of flipping a heads. So tomorrow we're going to talk about how we rationalize probability. We're going to talk about the probability of the event happening over the total options. So today I'm just going to have us rationalize just like Cameron did. So Cameron, if we have a 50% chance of flipping a heads, how do I write 50% as a decimal?
50% as a decimal.
And other people are welcome to give their input in the chat as well. So 50% is a decimal. How might you write that, Cameron? Wes was right in the chat. Good job, Wes.
Wouldn't it be 0.50?
You got it, girlfriend. 0.50, or you could write it as 0.5. Exactly. Good job. Again, when we are converting from percent to decimal, we write it over 100 and then we reduce. 50 goes into 100, or 50 divided by 100 is 0.5. Exactly. All right. Then when we want to write this as a fraction, we can go ahead. Awesome job reducing, Wes. We can go ahead and we can write our fraction or our percent as a fraction. So all percents are out of 100. So 50 out of 100 is one way to write our fraction. We could reduce that. 50 goes into 50 once, 50 goes into 100 twice. So my fraction reduced would be 1/2. Exactly. So theoretical probability is looking at your situation and saying, okay, this is what should happen. I should flip a heads 50% of the time. Does that always happen? If I were to flip a coin, is it going to go head, tail, head, tail, head, head, tail, tail? Is it going to be perfect 50%?
No.
Not necessarily, right? Yeah. That's all about chance. So the experimental probability is what happens if I were to say, go grab a coin and I want you to flip it 10 times. Maybe it might be 5 and 5. It might be 50%, but not all the time, right? So experimental is when you actually conduct the experiment and it's what actually happens. So theoretical is in theory what should happen based on my odds. Experimental is, you know what? I did it. And this is what happened. So an example would be example 2. So we took Cameron's quarter and we flipped it 10 times. It landed on heads, or it landed on tails 4 times. So let's go ahead and write this out as a fraction, decimal, and percent. So it landed on tails 4 times. Okay, well, if it landed on tails 4 times, how many times did it land on heads? I flipped it 10 times. 4 were tails. How many were heads? Good. Yes. Thank you for using the chat. Landed on heads 6. So this is what actually happened when Cameron flipped her coin. All right. So we want to write this as a fraction, a decimal, and a percent. So we want to talk about tails. Okay. So I flipped it 10 times and 4 times it was tails. How might I write this as a fraction? a decimal or a percent. Anyone can give me an answer. Choose either fraction, decimal, or percent, and then we will convert from there. So you can give it to me in the chat or you can give it to me verbally. So she flipped 10 times and it landed on tails, 4 of them. So Wes is saying 40%. Wes, how did you figure out 40%?
Because 4 out of 10 is 40%. Or, well, yeah, it's 40%. But
Good, perfect. So you actually made it a fraction first. You said 4 out of the 10 times. Exactly. Good job, Wes. So again, we're just rationalizing these through. We're going to learn exactly how to write probability in our next lesson, the first lesson of the unit officially. So Wes said, okay, 4 out of the 10, which is his fraction. Good. If you type 4 out of 10 in your calculator, it might reduce it because 2 goes into both of those. So it might tell you 2 out of 5. So as a decimal, 4 divided by 10 or 2 divided by 5 is 0.4. And then to go from a decimal to a percent, we multiply by 100. When you multiply by 100, you get 40. So that's awesome. Excellent job. Okay, that's it for our lesson. So again, we're gonna really talk about how to write probability in our next lesson, which would be next week in unit 8.1. But you guys did a really nice job just reasoning through flipping a coin. So we're going to talk about actually how to write that next week, but you did a really great job. So you do have some prior knowledge with probability, which is good to know. Your homework, so we're in here for 25 more minutes. So your homework is to work in IXL. I do want you to work on 2 different parts. So I'm going to backtrack real quick to the previous section. So I want you guys, and I'll write all this down for you, to work on N2, N3, and that is practicing converting from fractions, decimals, and percents. Again, we need this skill. I cannot stress it enough. Then you also will be working on some rationalizing with probability, which is EE1 and EE2. Okay, so that is your task. Before you do that, I want you to take a quick 5-minute break, come back at 10:30, and then again, I'll have this up. Y'all can go into IXL, and then we can do some practice before we take off. Okay, excellent job. Thank you guys so much for contributing. See you in 5.